Find the linearization at x equals a. Now there was two formulas that I gave to you guys last week about this. One I called linear approximation, which was f prime of a, and you multiply it times x. That is the estimated change. Okay, this is the linear approximation. Okay, that's the estimated change. But then there was another one that we called linearization, and that's pretty much the same thing, except you also have to add to this f of a. So this would actually find the estimated y value. This just finds the estimated change from the y values. Okay. So how do we do this one? This says find the linearization at x equals a. Okay. So the weird part, I guess, for this is that we don't know what delta x is. Okay, so because we don't know what delta x is, what would we put in the place of delta x?
X minus a.
You put x minus a.
But it says that x equals a, so shouldn't it?
Oh, yeah, it's freaking you out, huh?
Yeah.
Okay.
This is an outrage.
All right. I think what they're saying, that x equals a because of that a, like, because they're thinking that you're going to think of the formula, and so it's kind of confusing. I give you that, but so let me show you guys how you would do it. Now we're just taking out the delta x and we're putting x minus a in right here, and we're going to simplify this. So this is kind of like our formula. This is your linearization. This is how you're going to do it. So we have of a, because we're plugging in a for this one. But now we need to, so we need the f prime, which I don't need to write, we just need to find it. So we got to find f prime of this. So that means we have to use the quotient rule. So here we go. Here's the quotient rule. We got to take the derivative of the top, which is x squared, multiply it times the bottom, x minus 3. Then we have to subtract the bottom, the derivative of the bottom times the top. The derivative of the bottom is just 1 times the top is going to be x squared. And then we have to put that all over x minus 3 and square that. So I can simplify this a little bit to make it look a little nicer. This would be 2x squared minus 6x. Okay, so that's done with that. And then the x squareds go down to 1x squared because there's 2 and there's negative 1 right there. And then we get minus 6x over x minus 3 squared. Okay, so now we have, not at, sorry guys, not at a, we got to put 4 right there because it gives us a value. Alright, so the first thing we got to do is plug the 4 into f prime. So there's our f prime right there. If I plug in 4 to this, what would it simplify down to? Man, I'm kind of running out of space. A lot of them. So we can get rid of this. Okay. Alright, so this would be 16 right here, minus 24, and this would be a 1, right?
Yeah.
What's 16 minus 24? Negative 8. So we have negative 8 right here. And the next thing we had to do is multiply it times x minus a. What is a right now?
4.
It's 4. Okay, and then we have plus f of a. So f of a is going to be 4 plugged into that.
16.
So we get 16 over 1, which is just 16, right? Simplify. We get negative 8x plus 32 plus 16. So our final answer is negative 8x plus 48. So this is L of 4. The linearization at 4. Alright, now let's look at the next one. Now for the next one we have this sine squared theta, and I want to review with you what you have to do in order to find the derivative of that. Okay, so let's write that out over here. We got the derivative with respect to theta of sine theta, and I'm going to put this squared on the outside because it kind of makes it easier to think about. When you derive this, you got to derive the exponent first. So that means I'm going to drop this exponent down and take 1 away from the 2. So that's going to be 2 sine theta. But then I take 1 away from the 2, so it's going to be to the 1 power, which I don't need. And then I have to multiply this times the derivative of sine. What's the derivative of sine?
Negative cosine.
No, not negative cosine. Sine. Or I'm sorry, just regular cosine. Because sine is the good guy, remember? All right, it's the guys that start with C's that are bad guys. Okay, so that's our derivative of this guy. And the first thing we have to do is plug the a into our derivative. See f prime of a? So if I plug in pi over 4 to this, what will we get? We have 2 sine of pi over 4. Thank you. We have to multiply it by cosine of pi over 4. No. So we get 2 times rad 2 over 2 times rad 2 over 2. When I simplify that, these 2's are going to go away, and I multiply those, it's going to be 2. So we're going to get 2 over 2, which equals 1. And so the first part, the f prime part, the f prime of a, is just going to be 1. And then we have to multiply that times x minus a, but we have a value for a, so we have x minus pi over 4. And then we have to add that to whatever we get when we plug in pi over 4 to f. If we plug that pi over 4 into this, what will we get? Don't forget you have to square it. So it would be sine of pi over 4, and then you got to square that. So sine of pi over 4 is rad 2 over 2, and you square that, what's that going to give us?
1/2.
Yes, 1/2. Now I'm going to leave it as 2 over 4 because I see that we're going to have common denominators eventually anyways. You distribute the 1, it's not going to do anything, you get the same thing. So how would we simplify it the way this looks? We got x minus 4, or pi over 4, and we're going to add to that 2 pi. I'm sorry, just 2 over 4. So since these are constants, these are supposed to be considered constants, we want to combine those together. So I'm going to say it's 2 minus pi over 4, because we like to have the minus in the middle. And we're going to add to that the x. Oops, let's write equals L of pi over 4.
Do you prefer it that way, or is it?
Oh yeah, this is way this way to write it is more preferred because we don't like having hanging negatives like out here. I mean, I suppose you can have a minus here, and that would be a minus 2 and a plus pi. That would be fine too.
Okay.